As networks grow, tower capacity is being tested. Equipment is increasing. Radios are rising. Cabling is multiplying. This means tower owners, carriers, contractors, and engineers all have more questions about inventory, capacity, and safety. And when you don't have an answer, another truck has to roll. This process is slow, expensive, inefficient, and most of all, dangerous. At the same time, drones seem like a promising tool to provide answers and perform faster, cheaper, and safer inspections. But tower data is only as good as the sensor that collects it. And while off-the-shelf sensors provide rough visibility of inventory, they fail to achieve the level of accuracy needed for important cost and life cycle decisions. At the end of the day, a truck still has to roll. Visual intelligence does things differently. Instead of focusing on the drone, we set out to reinvent the sensor itself. And to solve for enterprise scale, we purpose-built a platform around our sensor, automating both tower capture and insight generation. We've designed the industry's first and only sensor software fusion, capable of delivering 3D engineering-grade tower data at scale. We're creating a digital twin of your entire portfolio. Every antenna, every coax cable, every nut and bolt, everything, down to the millimeter. Helping you see and measure where climbers cannot, improving team decisions with reliable tower information and AI-enabled insights, and establishing a core data set that will unlock new value across your enterprise for years to come. At the core of visual intelligence is the sensor. Our patented dual sensor technology is capable of consistently capturing 3D millimeter tower detail, generating billions of data points per tower to map even more measurable surface area. Through our exclusive partnership with Bentley, our end-to-end platform automates every step in the intelligence supply chain, from inquiry to insight. Effortlessly plan tower missions and dispatch operators, easily execute autonomous drone flights, automatically process data into highly accurate 3D models, and leverage AI to generate ready-to-send tower reports. Evolving the industry from 2 dimensions to 4, from manual inspections to inspection automation, and from truck rolls to visual intelligence.
Okay, good morning, good afternoon, or good evening, everybody, depending on where you're joining us from around the world today. So I want to say thank you for joining today's webinar, which is Digital Twins Unlock New Automation for Telecom, which is brought to you by Bentley Systems. Before we start the session today, I just want to give a couple of housekeeping announcements. Firstly, we will have a Q&A session during the second half of this webinar. Feel free to ask a question using the Q&A function at any point during the session. We'll just take all the questions towards the end. For anyone who would like to share this with a colleague, we are making the recording of this available as well as the slide deck, and so this will be sent to you after the event. There's also a resource center on the event website, which again will send you the information on this, which has various other presentations and videos that you might enjoy having a look through. So that concludes the housekeeping announcements. So I want to now introduce you to this session's speakers. So I'm delighted to introduce thought leader Ted Miller. Many in the industry will know Ted. Ted's the founder and former chairman and CEO of Crown Castle International, and he's the founder and chairman of Visual Intelligence. We also have Santanu Das, a senior vice president, chief acceleration officer of Bentley Systems, and they're accompanied by senior director Apurba Trivedi of Bentley Systems and Jay Tilley from Visual Intelligence. Bentley Systems is a software development company that supports the professional needs of those responsible for creating and managing the world's infrastructure, including telecom towers. Bentley delivers solutions for the entire life cycle of the infrastructure asset, tailored to the needs of various professions, the engineers, planners, contractors, and owner-operators who will work on and work with the asset over its lifetime. Bentley Systems employs more than 4,000 colleagues in 172 countries. Visual Intelligence is a unified drone platform that digitizes physical infrastructure with millimeter accuracy. Using patented dual sensor drone technology and proprietary enterprise software, visual intelligence is the industry's first solution for capturing engineering grade tower data. And some of you may see the press release that's just gone out, but Bentley Systems and Visual Intelligence have partnered together to help lead the telecom industry through the rapid transformation from 4G to 5G as multi-network operators are expanding their portfolios through consolidation. Ted and Santanu will be sharing the secret to overcoming data challenges of the tower industry and how to make the most of the industry's burgeoning opportunities. If I can ask you to move to the next slide for me, Santanu. So this slide just gives you a quick snapshot of what we're going to be covering today. So we'll start off with a state of the industry, which I'll hand over to Ted in a second to take this. We'll look at some of the challenges, industry needs. We'll look at the use of digital twins for telecom. We'll discuss engineering automation, and then we'll move on to the Q&A session. So Ted, if I can ask you to turn on your camera and your microphone for us, and please take over from here. There we go.
Okay, thank you, Laura. Good day, everyone. Appreciate you being with us. So I want to talk a little bit about digitization in the tower management of infrastructure. Having been in the business since the mid 90s, we created one of the first, if not the first, management database at Crown Castle. Of course, there were only two tower companies at the time, Crown Castle and American Tower, but we did what we could to put bits of paper together and drawings and ground-based photographs to have something to manage the tower network, which was being acquired basically every month. So 25 years later, I'll look at the business of managing infrastructure in the telecoms industry, and I don't find much that's changed. We have some drone pictures and some drone video, which is married with the legacy data, but really not much has changed. And at this point, after 25 years, most of the manual processes have been wrung out, and the efficiencies from a manual standpoint have been realized. So where do we go from being stuck in basically analog mode from a management standpoint of the infrastructure to really saving money and making the business more efficient? So the current state of the drone industry is such that it collects photographs for inspection, and sometimes engineers can interpolate from those photographs to the legacy data. But off-the-shelf drones, single sensor drones, cannot collect the kind of fidelity necessary to produce millimeter class data that engineers need to measure and to perform engineering analysis. So in our book, the key should be that data is foundational and it should be built upon. Hence, Bentley and Visual Intelligence have come together to offer a sensor and software platform designed to digitize and automatically update for inspection and engineering analysis. So one flight, collect all the data. You can inspect, but you can also analyze from an engineering perspective. So you have tower capacity effectively, which is the key. You have tower capacity in real time. In terms of the state of the industry, we have obviously rising operations and maintenance costs, aging infrastructure. Depending on where you are in the world, you're rolling out 4G, or 5G, and that's mostly on aging infrastructure where the capacity of the tower is unknown. So how do you get there, right? Our solution will allow you to collect the data necessary to have a digital twin. And what is that? That's the reality model of what's on the ground. There are only 4 kinds of data. You've got good data, which may or may not be good. Good data generally associated with new equipment or new tower, but do you really have the as-built drawings to go along with that new tower? You've got non-existent data, you've got bad data, or you've got okay data. In any of those 3 cases, you've got to roll a truck and you've got to climb a tower. So so it's time now to move from time to move from manual to digitization management with automated workflows, and from inspection engineering and interpolation to automated analysis with precision. Knowing the tower capacity today, not 60 to 90 days from now, is what's necessary. So speed to market is paramount, not only for the MNO or the carrier, but also for the tower company, in order to compress revenue and to put equipment on the tower for the MNO customer. We need engineering digital twins in order to be able to do that. I'm going to give you one example in terms of acquisition. So a 2,000 tower acquisition, sans accounting and legal, may cost you about $2.5 million, roughly, to do due diligence on 10% of the towers. We can reduce that cost significantly, give you inspection capability on 100% of those towers, and have the ability to later process that data for engineering analysis. So obviously, with one tower collection of the entire footprint, you now have the ability to integrate that footprint of 2,000 towers in a very short period of time, less than what is normal, which is about 1 year. I found that talking to towercos and MNOs that there's really not data sharing among the various divisions. If you look at a towerco or an MNO, you've got operations, leasing, legal, engineering, network management, maintenance, etc. And it's important that all of those divisions collaborate with each other. So what is the issue? What is the industry challenge? There are many challenges, but it can be summed into one challenge, really, and that is the precise data shareable across the enterprise allows collaboration with the enterprise and with trusted third parties to give you faster time to market and more efficient integration, less reliance on manual processes. So I don't think there's a lot more that can be said with regard to the challenge, other than I think across the board with the number of acquisitions that have taken place over the last 20, 25 years, with changes in engineering firms, changes with personnel in engineering firms, changes with personnel within an MNO, and their engineering department, or a tower company and its engineering department, data has been corrupted, and what's needed is a digital twin with millimeter accuracy that becomes the source of truth for the enterprise and for trusted third parties. Now, what are the stakeholder challenges? We've talked about MNOs and tower owners, but and who need immediately available and reliable data. And this is particularly important when managing an active network such as Vantage. Vantage will be managing the towers, and they'll be managing the active network. And frankly, I think that's the way the industry will go in the future. It'll take time to get there, but I think that's the way it'll go. So in terms of engineering firms and field operations, engineering firms, again, have to rely on climb data, which is unreliable, legacy data, which is generally unreliable. They do the best they can with photographs that are taken by drones and video taken by drones, and interpolate with the legacy data they have, but that data is not measurable. So the engineer continues to evolve the design and the planning on that tower based on data, legacy data that may or may not be good data, compounding the issue. I want to, if we move to field operations for just a minute, same thing, right? High risk operations, relying on drone data that is not precise. It may be good enough to inspect, but certainly field operations could be much more efficient and much more collaborative and add value to the institution if it could collaborate with leasing personnel, with engineering personnel, with construction personnel, with finance personnel, and on and on. So one example I think that is poignant is that my old company, Crown Castle, if you look at their 2019 reported OpEx, if they were to save 10% in OpEx with reliable, precise data, shareable across the enterprise, they would have an enterprise value impact of $1.4 billion. Now, you don't believe that? Cut it in half, 5%, 700 million. That's a big number. And that does not consider CapEx, compression of leasing revenue, and on and on. So there's big money that is in play here. So what are the drone solutions today? The real question is, why spend time and effort and money to collect pictures used only for inspection purposes and maybe for engineering interpolation, when that drone data is static in time, not measurable, and not automatically updated? Trucks still have to roll, climbs still have to take place. So with our solution, and what we're proposing here, is that one collection produces the ability not only to inspect at high resolution, but also to allow engineering analysis, and more importantly, to automatically update the tower structure and the equipment with each subsequent flight. So structural capacity is known today. It's known now. It's not known 45 or 90 days from now. It's known today. And the data is consistent because we fly the same profile, flight profile, each time when we update the data. So with that, I want to turn it over to Santanu to talk about digital twins and what a digital twin means to our business.
Thank you, Ted. Thank you very much, and good day to everybody. So Ted very succinctly explained the challenges we have in the industry today. And I think the term digital twin has been volleyed around many different industries. And I want to make sure that as we contextualize exactly how visual intelligence and Bentley are working together to produce a digital twin model for the telco industry, what exactly is a digital twin? So we go with a little provenance, a little history. Everybody's familiar with 2D CAD and the staticness behind it. That evolved into BIM, where a lot of people started using what was called information modeling to better understand exactly the different and disparate silos, that may come together in an industry: architecture, structural, electrical, mechanical. They all sort of came together, where you could kind of unify the views of these disparate solutions under one particular model. The problem with either of these solutions is the staticness, is how evergreen the digital model was and exactly how up to date that information was, and how much of aggregated data it could actually pull in, so that you could get one sort of unified single source of truth. And that really wasn't happening. People weren't getting an operational view of their asset. It was much different than the as-built. It was much different than the engineering. It was much different than the design. So the industry moved over to what's called digital twins to kind of give you that 360-degree, 24/7 view of your particular asset, combining engineering technology data, IT data, and operation technology data under one unified sort of model. And then depending on the lens that you were wearing, if you were a contractor, or engineer, or designer, planner, owner, you can extract the available information that you needed in order to kind of make the decisions and insights that were required for your asset. Now, a digital twin really has 6 kind of key parts. It could have a lot of other, extraneous parts, but it has kind of 6 different key parts. The first thing, as Ted was talking about, is 3D, 4D, and especially now 5D, to capture time, capture cost in terms of exactly how your model or your asset is progressing. It has to have some level of AI ML. Can it be able to determine components of that particular asset automatically? Can it detect differences between the asset automatically in different periods of time? It has to understand what's going on underneath the asset. This is extremely valuable today, especially with all of the changing climate phenomena. That's going to have a lot of impacts on your particular asset. You want to know what's going on before those changes happen underground. It has to have information about sensors. So real IoT data that's plugged in. So now you know everything about the radio line of sight frequencies, you have power management information, all that kind of stuff can also be added and augmented to your digital twin. Whether or not you need it today, whether or not you need it 5 years from now, you want to make sure that your digital twin is evergreen so that it has the ability to harness that information once it becomes available. And then it has to be collaborative. So when you look at things like augmented reality and mixed reality, it has to be able to be shared by other people inside of your workflow that don't have access to specific software and so forth. So those are the kind of key components of a digital twin. Now, when you apply it to the telco industry, as I said before, what we're trying to do is we're trying to make a digital representation of your physical asset by combining engineering data. So these are your normal drawings, your documents, your analyses that you run, your geotechnical information, with your operational data. This is all the drone information coming from visual intelligence that creates a reality mesh, point clouds, LiDAR, even IoT data. And then finally, your informational, your operational post data, which is your work order flows, your maintenance records, your inspection data. All of this stuff has to be sort of imbibed inside of this digital twin, and it has to be accessible. So it's not just good enough that you just throw all this data together and then each individual is up to themselves to be able to extract it. You have to make it accessible, you have to make it reasonable, and you have to make it something that you can extract data and provide insights, analytics, and so forth on there. And that's really the essence of the Bentley digital twin that we're performing with visual intelligence. Sorry, went back one step there. So if I look at it in terms of the workflow, the most important part obviously is the reality mesh. By creating that capture, that millimeter accuracy, that's really what starts the digital twin. Without that being effective, everything else sort of fails a little bit. You know, I kind of look at it as you have a beautiful sports car and you're putting 85 octane gas in it. Yeah, the sports car is going to run, but it's going to be trivialized, right? It's not going to be able to have performant value that it was spec'd out to be. And therefore, all of the services that you're going to have on that particular digital twin are going to fall a little bit short. You're not going to be able to apply the good AI ML. You're not going to be able to provide predictive analytics as well, because the accuracy of the model falls short. And therefore, if you look and kind of move around this circle, when you go to design and analysis, construction, operations, everything should come from that unified model. You shouldn't have to go to multiple repositories hoping that they're synchronized together to be able to extract that data. So if you're getting the new drone sensor data and then you're applying that, you know, and updating the digital twin, the wind load analysis should automatically apply to it. The automatic AI ML to detect the appurtenances, you know, on that should automatically apply to it. You don't have to be able to go and find another repository to match that. So that, again, that's the essence of the digital twin workflow. And this isn't our first rodeo. Bentley works with Microsoft to kind of host our digital twin in the back. And we've actually applied our digital twinning technologies to vertical assets like buildings. This is the Microsoft building in Singapore that we worked together with them. We applied our digital twin technologies to look at energy rates, occupancy rates, safety protocols, you know, real-time air conditioning and HVAC information on that building, such that owners could do real-time analytics and insights as to exactly how their building was being used, and if any changes need to be made at that time. So this was combining engineering data and operational data to be able to provide operational insights there. So again, with Microsoft's help, it's really, you know, one of the things that we always talk to telco owners is security of my data. How do I know if my data, if it's going to live behind your firewall, if it's going to live behind our firewall, who is going to be responsible for making sure all of the uptime and SLAs there? And that's why we partner with Microsoft to ensure that's there. And other companies have used it, like Bechtel, you see here, the Heathrow Airport. They've used our digital twin technologies to get a real life, you know, operational view of the airport that you have there. And this was done by Bechtel and Bentley. So again, applying it to the digital twin or to the telco world isn't something new for us. And therefore, partnering with Visual Intelligence really sort of kind of closed that gap. So kind of rehashing what Ted said there, the whole purpose of a digital twin is to be able to be predictive. You could be reactive if necessary. You want to lower your operational costs because you have all the data, what we call dark data, all those PDFs and drawings and Excel sheets and work order maintenances that are sort of siloed in the repository. That's all accessible too. You have one source of truth that has high fidelity. It's always evergreen. It's always being kept up to date. And it has ability for you to automate it. So if you want to automatically run inspection reports, run analysis reports, you want to do some kind of differencing between the as built and the as designed, all of that stuff helps to increase the efficiency there. And so that introduces and takes us to Open Tower IQ. That is the digital twin we are providing for telecom owners and operators to be able to do kind of what we call a 5-step process that I showed you before. Analyze, visualize, inspect, collaborate, and plan. That's the essence of Open Tower IQ. And like I said before, Open Tower IQ, the digital twin, has a lot of different parts to it. And no one starts off doing all of those parts. You know, it's probably not very practical to do so. There's sort of an evolution of your digital twin. And everything starts from the referencing, getting that reality mesh. And then you work your way through collaboration, 3D modeling, 4D construction, connecting IoT, and then doing actionable insights, right? And that's, again, that evolution takes time. But all of that stuff is really meaningless unless you get that millimeter accuracy data, that reality mesh correct in the beginning. If that's not correct in the beginning, then all of those other microservices that we talked about fall a little bit short. And therefore, when we go back to this digital twin and you look at all the different services that we provide, the mount analysis that we do, the performance dashboards to give you ratings in terms of, the co-location kind of stuff there, everything starts with that reality mesh. And that's why Visual Intelligence and Bentley have combined together, knowing the importance of the starting of the digital twin to really make that whole workflow that you see here much more productive. And with that, we want to kind of show you, I'm going to have Apurva Trivedi talk to you about exactly what does Open Tower IQ do, and then I'll follow it with some case studies of exactly how it's being used in the field today. So with that, I'm going to pass it over to Apurva Trivedi.
Thanks, Santanu. So as we're talking about data quality, let's start with a few models. So this is, of course, a reinforced monopole with flange connection. Let's walk around the RAT center to check defects or create mapping reports. Santanu, okay, sorry. This is the monopole where we are walking around the RAT center. This is another monopole with platform mounts. And this is a lattice tower with different types of bracing. And you can see the data quality over here. And it also is a testament of our high quality data. Now, let me give you a glimpse of the application itself. In Open Tower IQ, every tower has its own life cycle history, as well as the one source subtruth. The landing page shows the tower rating for the latest analysis of digital twin. And it facilitates active collaboration by comparing as built versus as designed model. For example, the region tool helps to cut a very thin slice, and you can measure an angle of a platform mount between as built and as designed models. As you can see for this model, the mounts are not aligned and must be rotated by 86 degrees. Similarly, an advanced viewer with multiple coordinated viewports can be used to take measurement directly on geolocated 2D photographs. Data extraction from a reality model is made easy by superimposing point cloud on top of the mesh model, along with precise measurement tools. These tools are very useful to take a millimeter level measurement, like pipe thickness, pipe diameter, bolt diameter, etc. Do you want to find the associated images to a portion of the mesh model? Just click on the mesh model. One of the most unique features of Open Tower IQ is the Design Model Explorer. It enables a collaborative design review process. For example, equipment on a tower can be isolated with color coding based on a user-defined KPI, like a proposed loading or for a given manufacturer and model name. Then we come to the insight. Powered by our innovative AI ML, with just one click, all equipment, including antenna, radio, and microwave dishes, are identified, and data then can be extracted to enable smart inventory management. Now the simulation tool. Again, a very unique feature to simulate your 5G rollout. Let's find out an empty mount pipe and add a new antenna there. Now use the sliding bars to position the antenna correctly, and then use the predictive analysis to calculate new rating of the tower. Next, the detection of the mount itself. With just one click, all the platforms can be detected along with mount pipes. So look at the color coding. Whenever you see there's a green line, it means it detected an empty mount pipe. It also means those are the spaces already available to have more loading. However, it's only a part of the story. As you mentioned, Open Tower is the one-stop solution. So we can now extract that data in an XML file for Open Tower Designer to consume. So this is Open Tower Design with a tapered monopole, and we just import the loading and see the magic happens. It automatically becomes a fully loaded model and ready for analysis. So run the analysis. It automatically calculates your wind load, does all kinds of analysis, design ports, and create a report. And it becomes ready for reviewing and stamping. Thanks for watching. Back to you, Santanu.
Thank you very much, Apurva. And again, the whole key of having a digital twin is to eliminate this dark data. And as Apurva said at the end of the video, what was very telling is that in a digital twin, extraction of that information or exporting of that information to any third-party application, service, or repository is very, very important. So a true digital twin makes sure that it doesn't lock the data into some proprietary format that you can't get that information out. Now, working with visual intelligence here, you'll notice that one of the things that we try to do is really emphasize the ROI through this whole workflow process. Ted started off talking about how the importance of the reality mesh and minimizing maintenance, operation, truck rollout costs are there. And I'm trying to now kind of bring that together to show you in a digital twin through case studies exactly how that happens, how you can generate almost 70% ROI, through using the OpenTower IQ and visual intelligence workflow process. So case number one, the simple data capture and 3D modeling. You want to have to get a reality mesh, which many of you guys are doing today. However, to get that into an intelligent 3D model is something that OpenTower IQ can do with visual intelligence. So being able to put those attributes and intelligence behind that and to allow it to be collaborated across that workflow is something, again, very simple, first thing that it can do. The second thing Apurva was talking about was measurements and change detection, as designed versus as built. You can overlay these two particular models together. You can then look at differences between them, extract data. You can even do things like QR code detections. We have very good comprehensive measurement tools, as Apurva was showing you, that allow you with the millimeter accuracy reality mesh to look at diameter of bolts and pipes and so forth. Of course, we then do asset detection and data extraction. And this is really for co-location engineering, kind of what if scenarios. We automatically detect the appurtenances, the dishes, the mount mappings. We allow you to do some swapping, export data, hook those things up to a component catalog as well. So you know exactly what type of data you have and comparing it against your own asset registry, detecting mounting frames and so forth. We have what if analysis, scenario analysis. So a lot of our telco operator users use it to do what if scenarios, deleting certain areas of the tower, adding new components onto them, automatically doing a wind load analysis to see if that's going to have fatigue, changing the height or azimuth of certain components as well. And then, of course, all of these scenarios can be saved for comparisons and legacy purposes. Engineering is actually very important. Having an integrated engineering service in there to do all your calcs and your designs per TIA, EIA, and other international codes are very important. Ted talked about mergers and acquisitions, as many telco companies are buying portfolios throughout the world. They, of course, have different standards, different loading standards and analytical standards there. And OpenTower IQ is built with all of those global standards as well to give you constant ratings of your asset portfolio in real time. And of course, as I said before, you can have a different lens depending on who's looking at this digital twin. So we perform the visualization capabilities to look at line of sight and spherical views, very good for radio engineers and operators to kind of see exactly, what is going on with the new additions that they're putting on their asset. And then, of course, the last one is maintenance. You want to look at defect detection. Are we missing bolts? Is there rust accumulating? Are there cracks in there? If there are QR codes or conditional assessments that need to be tagged to be able to put those back into an asset registry in there, those are also available with the AI ML tools that we have. And that's really the beauty of what we provide. Because of the openness, it allows the ecosystem to expand. We understand that every single service that we provide isn't maybe something that you may want to use. You may have your own in-home, ingrown analysis systems. Maybe you have your own AI ML system that you have built in-house there. The openness of it allows our ecosystem to extract information and apply their own stuff to it. So for example, Microsoft provides our IaaS, our infrastructure as a service, right? All of the cloud technology, the storage, the uptime, and so forth there. And of course, we have visual intelligence that provides us the data capture. You know, the openness into our digital twin allows them to integrate their data capture. And with that, I'm going to pass that over to Jay Tilley from Visual Intelligence to talk in more about how this ROI works and this partnership, you know, can actually get you going right away. So with that, Jay.
Thank you, Santanu. Hello, everyone. As we've seen today, the industry faces challenges that are answered by these new capabilities of millimeter data when combined with enterprise scale end-to-end processing. To illustrate the benefit of these solutions, I'm about to walk through some major business use cases that illustrate this leverage of the digital twin and this new open tower paradigm in terms of financial and operation related terms, answers. Basically, how does all this save us costs? So while inspection data has its place, next slide, it cannot realize the productivity and economic advantages of engineering grade data that's measured in millions to billions of dollars across tower portfolios and especially looked at on a multi-year basis. So to illustrate the business cases summarized here, I'm going to illustrate some of these operation and financial benefits to the tower code, field operators, network operators, engineers, and other telecom stakeholders. So for information sharing activities, we've hit on this pretty hard. This single collect creates an information value and a decision support across the entire enterprise, from order lifecycle to order submission throughout the post-modification, verification, maintenance. All these are produced from that single millimeter collect. This data has impact to order preparation, initial loading analysis and review, updates the design models in CAD, and generation of post-modification work orders all benefit from this digital twin information. In fact, the total cost for modification and order management could save up to 70% over current traditional methods. In addition, this cost savings also provides and realizes from upfront decisions, such as making decisions about what to analyze and what not to analyze. With that insight, with that ability to see that digital twin, you can now employ your resources much more effectively. To look at it from a temporal point of view, next slide, the total cost of ownership in terms of this illustration is across a 10-year life cycle. So looking at the 10-year life cycle for upgrades, and from our contact with the top 80% of the major tower codes and understanding their associated workflows, we have found that the potential TCO savings can be reduced by 42% per tower over that 10-year period, with even 3.7K saved in the first year. Where do these savings come from? They come from eliminating or reducing multi-skill site visits. They come from what's manual now, but now you can derive a lot of drawings from the digital twin and support your workflows and work order processes. Automated structural analysis that step off from the engineer's design model update, all conveniently provide to the Tower IQ interface, eliminating most clients, where external inspection and sourcing dimensional measurements now can be done automatically. And then, of course, work order documentation. This entire life cycle of value all translates into a total cost of ownership value to the customer, in this case, over 10 years. I'm going to now walk through a couple other use cases where substantial financial impacts are realized, one in leasing and one in mergers and acquisitions. On the leasing side, depending on the data quality and depending on current legacy data, the traditional lease time frame for a towerco ranges from 25 to 46 days. And it can cost $2,500 to $5,000 per tower, resulting in a 4 to 6 week revenue recognition delay. By employing digital twin class collection, this reduces the revenue delay to 11 days for new data collection if needed, or 2 days if that evergreen digital IQ digital twin is maintained, and then basically accelerating revenue recognition by about a month. This collect once digital twin solution positions the leasing department with much faster response times, often beating competition, and will increase revenue for the tower. Overall, the leasing pace is accelerated up to 95% faster and is 90% more affordable. Applying some financial structure to mergers and acquisitions, as you've already heard previously, the digital twin model benefits both M&A buyers and sellers by reducing their risks on both sides and accelerating diligence while realizing lower cost. So using 100% populated data room versus the classic 10%, accurate tower profiles reduces the M&A transition time by an estimated 33% and acquisition costs by up to 15%. Benefits both sides. Buyer CapEx, OpEx, risk is reduced with this full tower assessment. The seller wait period can be reduced up to 16 months, saving $1 million. M&A costs, as we've seen our 2,000 tower use case illustrated here. Furthermore, the seller can likely improve their margins by reducing the buyer's risk with greater tower situational transparency. And finally, and importantly, engineering. We get often asked about the engineering benefits associated with this. Basically, engineers gain significant productivity advantages without sacrificing their engineering role. Engineers get to engineer versus doing data management, document preparation, data validation, and use tools that improve their tower design and modification effectiveness, often reducing their engineering risk at the same time. So a lot of these translate into full tower and mount dimensional coverage. You can verify and pull measurements anytime without having to redo truck rolls or new climbs, trying to sort through legacy data. You can use your legacy data that you have and leverage right into our design tools and workflow, accelerating your design process. You can perform change detection and quickly flag unknown modifications, which helps your engineering process and maturity. The AI-produced equipment list that you've seen save time for report generation, automated structural analysis generation based on your designs that can now be performed and produced into reports, greatly improving efficiency. And frankly, we can even customize the reports to your specific report formats. And just as important, generating CAD files. This digital twin can derive other types of data structures and data files that can be used and distributed. So moving to the last slide here, a big point here is that millimeter accuracy creates the foundation by which all of this can happen. Looking across the spectrum of products and services that we've just discussed, as we go and rate millimeter versus centimeter accuracy, we find a much higher degree of reliability, a much greater degree of addressing the span of potential of these respective products and service products using millimeter data. Bottom line is that millimeter data is a foundation for a whole new way of managing towers for financial gain that leads to increased safety and reliability of your information. The digital twin harnesses a wide variety of data value impacting the entire market, benefiting field operators, engineers, tower cos, MNOs, and this capability is ready to address your use cases. Next slide. So we've now walked through a number of different use cases. What I'd like to do now is transition to our last slide, and in terms of call to action, up on your screen now is a contact us link, opentower.com/free consult, and now we'll open ourselves up for questions. Thank you.
Thanks, Jay. Thanks, everyone. So yeah, like I said, we're opening up for questions now. I can see a few have been coming through to the chat. If you haven't managed to ask your question yet, please do drop that into there. So I've got some great questions come through. So I think I'm going to start one probably best suited to you, Apurva. So it's looking at a question, do you have any asset management systems? Can we integrate OpenTower IQ with an existing in-house database? There we go.
Yeah, absolutely. Oh, yeah, absolutely, we do. So our whole system is based on Azure, and we use Azure SQL Server to create our asset management database. And on top of that, we actually integrate with our ALIM or our AssetWise Lite platform. So we definitely have the asset management system. And that can be not only just for the getting the data or storing the data, we also have our open API layer. And through those open API layer, you should be able to integrate to any existing asset system, or even for the unstructured data. Like say if you have Excel, PDF, if you want to from unstructured, if you want to put it in structured database system, we have our integrators, our iModel integrators and connectors. That's what we call them. So yeah, we definitely do have it, and that's something we definitely take pride in.
Superb. Next question I've got is actually, we've had this question in various forms from multiple people. So is looking at how can your sensor collect engineering grade tower data? So what kind of coverage do you achieve, especially underneath platforms and complex lattice structures?
I can take that. Or is there anybody else?
Jay,
Jay, sure.
Jay,
go ahead.
perhaps you?
Yeah, maybe I'll grab that one. So the design of the sensor has two major differences from typical competitors. One's resolution and one's coverage. And the way we fly that sensor, we make sure that the coverage in terms of the orbit design and based on leveraging our sensor design, which is 120 megapixels, allows us to have visual access from multiple angles to multiple points on the tower. We can do this from a distance, extended distance from the tower, and the combined capabilities result in a full coverage of that tower at millimeter class from top to bottom, including even the compound areas that are also integrated, provide a dimensional foundation for those that are interested in the site structure.
Thanks, Jay. Another question we've got is, can you create a CAD model from OpenTowerIQ? Maybe a PURBA.
Sure, yeah, we can definitely create a CAD model from OpenTowerIQ. So there are two ways to do it. One is the data extraction, which we can do from the reality model. And then because we have Bentley, so we have MicroStation, so obviously we can automate that drawing process. The other way to do it is our iModel. So if you have a design model, that design model, we can author the design model through OpenTower Designer, and then it becomes the iModel in our iTwin viewer. And then we have the connectors, or we have the integrators, which actually can provide the beam model. You can actually save that iModel into MicroStation and start producing a lot of drawings from there.
By the way, it's not just limited to MicroStation. It could be AutoCAD, it could be Revit, it could be really anything, right?
It could be any CAD, yes, yeah.
It's coming back to the sort of drone technology itself. So one of the questions is, why can't a P4P or Mavic collect the same data by flying closer to the tower? Jay, maybe do you want to take that one?
Yeah, that's a good question, and we get that question quite often. The essence is that those systems have cameras that have a wide field of view, and even if they fly closer to the tower, what we call pixels on target is much reduced in ratio compared to what our sensor does. So we have more pixels on target. Our optical quality is such that we're able to reduce our GSVs down to sub-millimeter and still collect good quality information. It's very difficult for these other cameras, which have smaller optics, smaller detectors, to collect the quality of information while maintaining the resolution and maintaining the coverage needed to produce a good 3D model.
Mm-hmm. And then, so another question. So we're getting lots of questions coming through now. So what would a rollout look like? So how would I get started using your solution? Maybe Jay, do you want to pick that one up?
I'll take it up, and maybe Bentley folks can answer this too. So once we understand your workflows and product needs, we can provide a recommended product services package. We call them tiers that combine with collection plans, and together that, once we understand that clearly, we can, and also your legacy data and what's available, we can now understand how to structure a solution for you. Sharing your legacy data provides us a way to understand the best services to meet your needs. It could include change analysis, it could include updates. We may be able to provide data management service or interface to your existing databases as desired. But the real key here is impacting your workflow and having you be able to realize some of the benefits that we have just walked through in your use case.
Mm-hmm. And Jay, sort of a follow-up question to that one is about, obviously creating the digital twin for the first time, but then once the solution's being deployed, what kind of engagement would you have with the team? So, do you need specific technicians to keep updating all the information? Is there a regular point of contact? I don't know who wants to take that one.
Yeah, I mean, basically, a digital twin has to be evergreen. And so once you scan the first tower, so let's say you have a 2,000 or 3,000 tower portfolio, we always recommend starting smaller. Start with 100 towers or so, get the scan done, get the reality model process, put it into Open Tower IQ. Now you have a living, breathing digital twin to start with. Every year, every 2 years, depending on your update, procedure, your work order procedure there, you'll have to get it rescanned, again. Then we will do the diffing. We will store the multiple different provenance or historical views of the tower, so you can do comparison and things like that. And it's supposed to be really hands off, other than, of course, somebody actually physically flying the drone and taking the capture and putting, everything else is all automated. The upload is automated. The processing is automated. The detection is automated. The analysis is automated there, right? So, the scanning process to actually go fly it is really the only interaction. And if you have your own in-house team, you sub it out to another third party, that uses, visual intelligence or others. That's really the only interaction that's necessary. And that's the beauty of a SaaS cloud-based, solution there. It's instant on and sort of active.
Mm-hmm. And if I could just add on top of that, Open Tower IQ is actually built with this purpose. So it has the history of its life cycle. So once you initially capture it, that becomes a project. For every tower is a site, and every site can have as many projects as needed throughout its life cycle. So if we're using the digital twin for next 10 years, and you have like 10 projects because of various reasons, so those all becomes an individual project and can be maintained under the same site, and those projects can be dipped. They all could be compared, have change detection. So you have the whole history built into it. So this Open Tower IQ is actually built for this purpose.
Next question. I don't know if you're going to be able to answer this one on here. It might have to be something for follow-up, but let me know if you can. There's a question about which telecom providers are already using the solution. Is that anything that you guys are able to share, or is that maybe a conversation you need to take separately?
I'm not sure if we can give those names in this meeting.
That's fine. We'll kind of park that one, and maybe it can be sort of separate conversation. So question here, could you describe in a little more detail the synchronization of Open Tower IQ and Open Tower Designer?
Yeah, absolutely. So from Open Tower IQ, Open Tower IQ has two parts of it, right? So in our case, digital twin means, like Santanu was saying, it's not only a reality model. So drone capture is a reality model. It has to have a design model and a sensor. So and of course it has to be on a time frame, meaning a 4D. So in 4D, if we have a design model, a reality model, and the sensor, then it becomes a proper digital twin. And our design model and our reality model are always in sync. So whatever data we can extract using our AI ML, say all the loading data, say you have a RAD, and for that mount, you're actually going to get, there are new loadings, or you want to get the as-built information. Once you get that as-built information data extracted from the reality model, you should be able to push that data seamlessly into Open Tower Designer. So Open Tower Designer will be able to consume that data, give you the new capacity, and that data and that model again will be republished, in the iTwin viewer or in Open Tower IQ. So the integration is through our AI ML layer, and we also use the same open API technique like the one we share. So yeah, it's possible. It's a completely connected. One's author it, other one consumes it. So it's an integrated process.
Great. We're starting to run out of time here, so I'm going to ask one last question, and then I think I know we've got a lot more here, but I can see who's submitted those questions, and we can ask the team to follow up with everybody individually off the back of those. So I think last one to take. Sorry.
Sorry, I was saying there are a few questions on the Lattice Tower because we showed the demo on the monopole. So I'm wondering if I can share my screen quickly and show
Sure.
one of those models. All right, so let me share screen. Oh, I think Santanu, you have to stop sharing. All right, very quickly. So one of the question was that if we can do the Lattice Tower as well as we do the the monopole. Yes, we can do. I tried to show it in one of the demo, but yes, this is a lattice tower. Of course, it's possible. We have the similar and very high precision data over here. And as you can see, and this is all can be, you can switch up the design model if you just want to see the reality model, or you can turn it back, right? And I think there was another question where we are trying to understand that, let's go back to the model, and the different views from tower codes and the operators. So we actually have that already built in. So if I go to the equipment filter, and if I do the type, that's showing the type of different types of equipment. However, if we can click on operator, it actually gives you that the operators who are actually using it. So for different RADs, we can have different operators, and those all can be filtered, and those all can be placed in such a way that becomes a report by itself, including technology. So depending on what technology, say you have a 5G technology, 4G technology, those all could be separated, and those all could be shown on the screen.
Brilliant. Thank you, Purba.
Sure.
So I think we're actually going to have to run out of time here. Santanu, I don't know if you can just reshare your screen so we've got your contact details up on there for everybody. But I want to say a big thank you to all the team who've been sort of presenting today. I think it's been a really interesting session, and I think the number of questions we've not managed to get through, a testament to that as well. So you can see there's link here that you can kind of contact the team through. We will send out an email to everybody afterwards where you'll have the recording. I know some people joined partway through, so you'll be able to catch the beginning of the session. And we will also be able to send through the slide deck to you, and we'll redirect you towards all the other resources. So I think I will wrap things up here. Once again, with a big thank you for everybody taking part in today's session. I hope that you will have some really valuable discussions afterwards with the Bentley and Visual Intelligence team. So thanks so much, everybody.